Hey guys, today we're going to go through how to balance chemical equations coming from Unit 4, Lesson 3. This is really important because it builds on this for Lessons 5 and Lesson 6 and the lessons to come. And so it's really important to know how to balance chemical equations. I'm going to pull from the exact problems from your lesson that have to do with balancing equations from Unit 4, Lesson 3. So just keep that in mind. I don't have the numbers listed on here, but this is an exact problem from your lesson. What you're going to need to do these problems is this list of the ionic charges of elements. You could look this up online, or you can find it in my student resource folder, where I have above each column or group or family the charges that those elements in that column tend to have. And so we'll refer to that in a minute. We also need to know which elements are diatomic, meaning when they're by themselves, these elements, when they're in the form of a gaseous state, but whenever we refer to them, they're always going to be doubled rather than single. And so they're kind of unique in that way. And so you have to remember that these elements are diatomic. And so let's go through the first one. We need to balance this equation. Before we balance it, we need to actually write the equation out. So it says sodium chloride reacts with fluorine gas to produce solid sodium fluoride and chlorine gas. So we need to make formulas out of these. And so we need to find these elements on the periodic table. And so I also have like a copy of my periodic table here, so I can zoom in a little bit easier. But you can see that sodium is Na, right? Sodium chloride. And we can see that chloride came from chlorine. Things tend to end with IDE, ide, but like they always come from something else. So like fluorine becomes fluoride, chlorine becomes chloride, oxygen becomes oxide. So sodium chloride, that chloride came from chlorine. And so what we need to do is we need to write those down and make a formula out of them. So we know that sodium is Na, and we know that chloride is Cl. And we need to figure out like how many of each. Is it like NaCl, or is it Na2Cl1 or NaCl3? How many of each do we need? And because this is an ionic compound, a metal and a nonmetal, we have to look up their charges. So going to this list here, sodium is right here, and it has a +1 charge, okay? Chlorine is right here, and it has a -1 charge. So when you look at that here, +1 and -1, the charges cancel out, and so there will be no need to cross over anything. So the net charge is supposed to be 0, and it is 0. So we're all good to go. So we know that because it's +1 and -1, it's just going to be NaCl. It reacts with fluorine gas. So it's just pure fluorine. There's no like it's not like sodium fluoride. It's just fluorine. We know that fluorine is F on the periodic table. You can go look it up to double check that fluorine is just F. But fluorine is one of the diatomic elements. So when fluorine is by itself, not in a compound with another element, it's going to have a little 2 next to it. It always exists as a double. It reacts with fluorine gas to produce. So we do an arrow for that. When you see the word produce, you do an arrow. Solid sodium fluoride. Okay, so we know that this is going to be sodium, which is Na. And we learned earlier that Na had a +1 charge. And then fluoride is F. But what charge does fluoride have? Fluoride has a -1 charge based on its location. -1. So again, thankfully, these are going to cancel out really nicely. So we know that they're going to be just Na1, F1 like that. And so we do a plus sign. When you see and or with, you do a plus sign. Chlorine gas. Well, what's the symbol for chlorine? Let's look over here. You might think that it's C, but the symbol for C is carbon. Chlorine is Cl. Cl. And it's just chlorine gas, and so it's going to be Cl like this. But chlorine is also one of the diatomic elements, and so when it's by itself, we're going to double it. So now that we have our base equation, this is our base equation, we need to make sure that it's balanced. We need to make sure that each element on each side adds up to be the same. So now we have to ask ourselves, how many NAs are on the left-hand side? Well, this says NaCl. I'm going to zoom in a little bit for y'all. NaCl. That's just one Na. If there is no subscript there, there's an invisible 1. You can assume that it's just 1. So there's one Na on the left, okay? And then when you look on the right, there's also one Na. So far that's balanced. On the left for Cl, there is also one Cl right here, right? On the right, how many chlorines are there? Well, when you look here, this says Cl2. That 2 is telling you how many of the previous element there was. So there are 2 chlorines here, right? So this is not balanced. We have 1 chlorine on the left, but 2 chlorines on the right. That's not balanced, and it doesn't make sense that you can just start off with 1 and all of a sudden have 2. So what we can do is we can put a coefficient in front of the entire compound. I cannot put it here, and I cannot put it here. So we can't put a subscript in front of the Na or in front of the Cl or anything like that. But we can put a big coefficient in front of an entire compound. I could put one here, 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 or here. Anything between a plus sign and you can put a coefficient and double the entire thing that you're dealing with. So I can put a 2 here, and that 2, when that happens, it's important to know it multiplies to everything within the compound right here. It doesn't multiply to the F. So now that I put a 2 there, now I have 2 NAs because it's 2 times 1, and I have 2 Cls because this 2 multiplies to everything within that compound as if there's like a parenthesis here, and it's multiplying to both of them, okay? So now I have 2 NAs and 2 Cls. Now my Cls are balanced, right? But my sodiums are now off kilter. I have 2 NAs over here and only 1 over here. So I can also put a 2 right here, and that 2 will again multiply to everything within this compound, not after the plus sign. So now I have, when you multiply that 2 out, I've got 2 NAs right here, okay? So my NAs are good. And now let's look at my Fs. So on the left-hand side, you can see that I have 2 fluorines right now. There isn't a coefficient here, and so it's just a regular 2. And then for the F over here, I have just 1 F right here, but when it multiplies out, it becomes 2 times 1, so I have 2 fluorines. And so now the numbers of each element are the same on both sides, and my equation is balanced. So let's try the next one, and I'm going to go a little bit quicker on these on writing the formula out, because when you have answer options like A, B, C, D, you can kind of decipher and move past this a little bit quicker. So potassium on the periodic table is K, and iodide is I, okay? When you look them up right here on the periodic table, here's K and here's I, iodine and potassium. Potassium has a +1 charge and iodine has a -1 charge. And so +1 and -1, they're going to just cancel out. +1 and -1 and just be Ki. So it says aqueous potassium iodide. So aqueous is just the state that it's in. It means that it's dissolved in water. I don't really like to include that information because I want it to be simple. So it reacts with, so I do a plus sign, lead to nitrate. Lead is Pb, and Pb on the periodic table has multiple charges. When you look at Pb right here, you can see, for one, you can kind of see right here that this is kind of iffy, like what's plus or -4. But in general, Sn and Pb are kind of like transition metals. They don't have consistent charges. And so this Roman numeral tells us so that it has a +2 charge. That 2 right there tells us the charge. And then nitrate, it ends in 8, not "ide." And when something ends in 8, it's a polyatomic ion. You can get this list from your table A4 in your chemistry reference guide. When you find nitrate right here, nitrate is NO3 with a -1 charge. And so this is NO3 with a -1 charge. So these charges need to cross over. They don't cancel out, right? It's not like +2 and -2, or +1 and -1 like before. So what it's going to be is Pb NO3, 2. Because if I have 2 NO3s, then my charge would be on the left hand, there would be 2 -1 charges, right? And that would add up to be -2. So if I have 2 sets of NO3, then I would have a -2 charge overall, which would cancel out with my +2 charge. So another quick way to do it is called the crossover rule. Whatever your charges are, if they're not the exact same, that 2 is going to go here, and that 1 is going to go here. So it became PbNO32, but we need to put parentheses around it whenever we do it. So it's going to be PbNO32. You can also double check these by looking them up online, but I want you to know, how I'm doing it. Potassium nitrate is K with a +1 charge, and NO3 with a -1 charge. Those cancel out really nicely, so we don't have to do any crazy crossover rule stuff there. So KNO3, and solid lead 2 iodide. So remember, lead has a +2 charge, and iodine has a -1 charge. So we need to cross those over. The 2 will go here, and the 1 will go here. And so it's going to become PbI2. And now we need to balance it. So let's look at, first of all, the NO3. So let's look at N and then O, okay? So how many N's do I have here if I zoom in? This is important to look at because you're going to have a lot like this. So how many N's are here? Well, there is just one N inside there, right? There's nothing, there's kind of like an invisible 1 right there. But you see this 2 right here? This 2, because there's parentheses, it's going to multiply to both substances. So that means that there are 2 N's, because 2 times 1 makes 2, and there are 6 O's, because 2 times 3 makes 6, right? Basically, I have 2 sets of NO3. When I look on the right over here, when I have N and O, there's not a subscript on the outside. So I have 1 N and 3 O's. Remember that this 3 only applies to the O, not to anything else. But when you have a subscript outside, out in a parenthesis, it applies to everything on the inside and it multiplies. So I have twice as many, right? So what I need to do is I need to make these even. So I could put a 2 right here, because then that 2 would multiply to everything within it, right? And so that would make me have 2 N's now, because 2 times 1 makes 2. And then 6 O's, because 2 times 3 makes 6. So then that would be balanced. Now let's look at my K's. On the left-hand side, how many K's do I have right here? I have 1 K, right? And on the right-hand side over here, how many K's do I have? Well, there's just 1 K there, but this 2 multiplies to everything within that compound. So I actually have 2 times 1, or 2 K's. So these are not balanced. I need to put something here to make it the same number. So what can I do to make me have 2 K's? Well, I could put just a 2 here. That 2 would multiply out, and now I would have 2 K's there, and that would be balanced. And now I need to look at my I's. Okay. So on the left-hand side, I have 2 I's, because that 2 multiplies out, right? So 2 I's. And then how many I's do I have on the right when you look here? Just 2 of them, right? Because there's no coefficient here, so it doesn't multiply or anything. And so you just look at this, and that's how many it has. So my I's are balanced on the left and on the right. And then the last substance is Pb, okay? On this side, this 2 only applies within the parentheses, okay? Pb is outside of that parentheses. So I just have 1 Pb. And on the right, I also have 1 Pb. So basically what I did was I put these coefficients in front in order to figure out, in order to make the number of each element the same on both sides, okay? Now I'm going to show y'all for the last one a quicker way to do it. If you want to, or I mean, it might be quicker, it might not be quicker for you, but you can also just look at your answer choices. And so for this last problem, we'll do it that way. So you can see here, let's just go through and find the equation that's balanced and also the most reduced. So when you look, let me zoom in here. we need to choose the one that's balanced. So we have to look at each element. So how many carbons do I have on the left-hand side in this situation? Okay, I have 8 on this side. And how many carbons do I have on this side? Well, it says 7 CO2. That 7 multiplies out, right? So I would have 7 carbons. So this is not balanced, right? It's like 8 and 7. So this cannot be our answer. Okay. Let's look at this one. How many carbons do I have here? Well, I have 8, but it's times 2 because that 2 is in front. It multiplies to the whole compound. So I have 16 on the left. And then how many carbons do I have on the right? I just have 1 carbon right here, and it multiplies to that 16. So I also have 16. So that's balanced so far. For my H's, okay, 2 times 18, that's a fun one. 8 times 2 is 16. So I think that's 36, right? 36 H's, 2 times 18. And then how many H's do I have over here? Again, it's 2 times 18, so 36. So that's balanced. And lastly, I need to look at my O's. On the left-hand side, I have 25 times 2, or 50 O's. Wow, that's a lot of O's. On this side, you have to be careful because I have oxygens here and oxygens here, and they need to be added together. So this 16 multiplies times that 2. So what's 16 times 2? 32 O's, right? Plus the O's over here, right? 18 times 1. There's an 18 in front and then just a regular 1. So 32 plus 18. This is looking pretty promising. 3, 4, 5, 50. Okay, so I have 50 oxygens on the right and 50 on the left. And so this is completely balanced. But you have to double check, is this the most reduced version? And it is. Basically, like this is a 2, this is a 25, this is 16, and this is an 18. That's the most reduced version. This is the most scaled down version of it. You can't divide all of these by a 2 and get a whole number still. So this is going to be our answer just by looking at it and kind of just going through. So another option is just to look at your answer choices and kind of work it out and see which one has the balanced equation written in for you. So that's all that I have for you today. This is from Unit 4, Lesson 3. If you have any questions, please join my classroom and I'm happy to help.